All right, today we're talking about how do we use variables in formulas. So a formula is basically just a set way to solve a problem. So in this example, we're given the formula for finding the area of a triangle. So we have this formula here, which tells us that A represents the area. So the area is going to equal 1/2 times B, which is the base, times H, which is the height. And so in a triangle, we'll often be given a value for the base and a value for the height, and we would plug or substitute in those values into this formula. So this formula is almost entirely composed of variables, but when we're given values to substitute in for those variables, then we can start to solve it. So let's go ahead and look at how we would do that. Here, we're given the base of this triangle, we're given the height of this triangle, so I've plugged them or substituted them in to the formula. Again, the area equals 1/2 times the base times the height. Well, there's my base. So there's my base, there's my height, and now I can go ahead and solve this problem out. Often I will recommend that we solve, if all of the numbers are being multiplied, solve the two whole numbers first and then worry about the fraction. So 3 times 2, that gets me 6. 6 times 1/2, well, it's just half of 6, so that equals 3, and that's all that's left. So I'm saying the area of this triangle, the area is the space inside of the triangle. The area of this triangle is 3. Now we can also use this to find the area of a square. So the area of a square is equal to one of the sides, S is side, one of the sides squared, which squared, this is a number called an exponent, and we'll get more into them later this year, but this exponent tells me that I need to multiply this number by itself. So S times S. I have 2 S's there. That's what this number tells me. So S times S. And again, remember S represents the side. So if I'm given the length of one of the sides of a square, and keep in mind that all of the sides of a square are going to be the exact same. So if this is 3, then that's 3, that's 3, and that's 3. They're all going to be 3. So if I'm given the length of one of the sides, I can substitute in this value for S and solve my equation. So the area of a square, again, area tells us the space inside of a shape. The area of this square is going to equal 3 to the power of 2, or 3 squared. Now, again, this is just whatever this exponent is tells us how many times I multiply this. So 3 times 3. I have a 2 as my exponent, so there's 2 3's there. And 3 times 3 is 9, so the area of this square is 9. All right, one more example. The area of a rectangle is the base times the height. Now, if I'm given a value for the base and a value for the height, I can substitute those values into the problem and then solve. So here's my base. So I plug in the value for the base, which is 5, and here's my height. I plug in the value for the height, which is 2, and I can solve it out. 5 times 2 is 10, and the area of this rectangle equals 10.